A wayward rocket stage slams into the moon. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. Millions of people across Europe had the opportunity to see something truly spectacular last week. Kate Howells, the Planetary Society's public education specialist, shares her experience witnessing the 2026 total solar eclipse from a canyon in Spain. Then, Jared Head, producer of TMRO and museum facilitator at Columbia Memorial Space Center, breaks down how a SpaceX Falcon 9 upper stage ended up crashing into the moon and what it means for the future of cislunar space. Plus, Jack Corelli, the Planetary Society's newly minted chief of advocacy, gives us an update on the fight to protect NASA. Then we'll wrap up with Bruce Betts, our chief scientist, for What's Up. We'll talk about the spaceship graveyard in the South Pacific. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Last week, on August 12th, a total solar eclipse swept across parts of the northern hemisphere. It crossed Greenland, Iceland, and Spain, along with a couple other countries. It was Europe's first time to see a total solar eclipse in 27 years. But for people living in Spain, specifically, it was the first total solar eclipse since 1905. You all know how I feel about total solar eclipses. We are so profoundly lucky to live at this moment in time on a world where total solar eclipses are even possible. And if you caught our July episode, Small Town Universe, you may have heard Kate Howells, the Planetary Society's public education specialist, talking about her plans to catch this eclipse from Spain on her honeymoon. Now Kate's back to tell us all about it. Hey, Kate, welcome back.
Hi, Sarah. Thank you.
I have to hear what your adventure was like seeing this thing, because the images of this eclipse I've seen so far are absolutely mind-blowing.
Yeah, it was unreal. Absolutely perfect weather, not a cloud in the sky. I was super lucky to get to witness this eclipse from a very beautiful location. I was on the edge of a canyon with one of the most beautiful views I've ever seen in my life, regardless of having an eclipse. It was just a stunning, stunning vista, and the eclipse itself was absolutely magnificent. I've seen another eclipse I was at the 2024 eclipse in Canada, but in a very different context. It was in a city park, and it was very cloudy, and there was tons of people around, and it was magnificent. This time it was, on the edge of a canyon, just me and my husband, no one else around, absolutely perfect clear skies. I won't say that it was better this time, because every eclipse experience is amazing, but I just feel so incredibly lucky to have gotten to see two now in my life.
That is so magical. Like, I've seen two of them now. The first one, absolutely clear skies. The second one was magical in a different way because of the cloud cover and the fact that the sky opened up just at the right moment. But the images I'm seeing out of Spain right now really show how special it is that this eclipse was so close to the horizon. People got these beautiful kind of sunset eclipse images. Did that change the experience for you?
Yeah, absolutely. So again, we were in this national park on the edge of this canyon, and it had been a very adventurous drive to get to this spot. And so as soon as the eclipse was over, my husband and I said, okay, we should probably get back to the car and drive down, because we didn't want to be driving on these very off-road roads at night. But we thought, okay, we'll stay just a little bit longer to catch the sunset, because it was only about 30 minutes after totality that the sun started going down over the edge of the canyon. And it was so worth staying and kind of risking the dodgy drive, because seeing the sunset, that's a time when you can actually look at the sun when it's low on the horizon and it's that sort of reddish color. And it was partially eclipsed still at that time. So seeing this blood red crescent sun going down over the edge of the canyon, unreal, just absolutely magnificent.
Did you see any prominences or anything during totality?
Yes. There was one very prominence, and that's just it adds so much to the enjoyment of what you're seeing, to know that you're looking at solar activity. You're seeing huge bands of plasma coming out of the sun. That is so freaking cool. Seeing the blackness of the center of the eclipse, and then the corona just so bright, so visible, and then noticing that little prominence. It was extremely cool.
And I'm just living vicariously through you. That sounds so magical to be able to see a total solar eclipse, then go and see the Perseid meteor shower, and all of this as a wonderful way of celebrating your recent wedding and going on a honeymoon to do this is just like, that sounds like the dream.
It was very special. And I think we appreciated too that we managed to find a very isolated spot to watch the eclipse. It felt like a very special moment shared between the two of us. And again, that's very different from how awesome it was in the 2024 eclipse to be in a park full of people and families and hearing the kids just screaming and losing their minds at the eclipse. That is a super special experience to get energized by all the other people, but then also spending it just me and my new husband. I mean, gosh, couldn't have asked for a better honeymoon.
Well, I'm glad you had such a beautiful trip and got to witness this with beautiful, clear skies. And I'm so happy for everybody else who got to see this. And Spain is very lucky. They get to see this again in one more year. So I know a lot of people who missed it this time are probably going to be excited to see it again next time.
Absolutely. And I hope for clear skies next year. We got lucky. It was raining the day before and the day after the eclipse. So very lucky to get clear skies. I hope that everyone next year gets the same good luck.
Well, thanks, Kate, and thanks for coming back to tell us about your adventure.
Anytime. Thanks, Sarah.
The images coming out of this total solar eclipse are some of the best that I've ever seen. If you want to see them for yourself, we have a new article called The Best Images of the 2026 Solar Eclipse. As I mentioned in the conversation with Kate, Spain is going to get an opportunity to see a total solar eclipse next year as well. That's going to be on August 2nd, 2027. But Spain won't be the only country able to witness this over 6-minute total solar eclipse. It's going to move across southern Spain and Morocco. Then it'll proceed into North Africa through Algeria, Tunisia, Libya, and Egypt. I hear the Luxor is going to be a very spectacular location to see it. Then it moves through the Arabian Peninsula, crossing Saudi Arabia and Yemen before it goes into Somalia and then the Indian Ocean. If you want to go see it, I'd recommend trying to book your travel now, because this is going to be one for the ages. But now for something completely different. You may have heard that on August 5th, a spent SpaceX Falcon 9 upper stage slammed into the moon, and not on purpose. It crash landed and blew a new crater into our closest neighboring world, moving roughly 8,700 kilometers per hour. That's about 5,400 miles per hour for those in the United States. The story made headlines everywhere, and I knew exactly who I wanted to talk to about it. Jared Head is a museum facilitator at Columbia Memorial Space Center, a producer on the spaceflight show TMRO, spelled TMRO, and co-host of All Space Considered at Griffith Observatory. If it launches, lands, or in this case, crashes, Jared probably knows about it. He's here to walk us through what happened and what it means. Hey, Jared.
What's up, Sarah?
I'm so glad to have you here.
I'm glad to be here too. It was so much fun working with you at Griffith, and now we get to be here in the house that Carl built and talk about stuff I like, which is rockets.
People on the show who've been listening for a while know that DART was my first rocket launch ever, but they don't know you were the person that took me to that DART launch. So
yes, and that was a really fun night, I gotta say. So
that was so cool.
Night launches are always spectacular. I remember it was like foggy near the launch site too, so we had to throw a Hail Mary and go somewhere else.
Like in the middle of a parking lot somewhere.
Yeah, at like almost midnight to watch it. But
it was so worth it.
As I said at that time, and I'm going to say once again, we got to watch humanity avenge the dinosaurs. So take that one, asteroids.
But now, anytime something really cool happens in rocketry, you're always the first person that pops into my head. Not just because you were the first person to take me to a rocket launch, but of all the people I know on Earth, you have just this unbelievable historical knowledge of what's going on with rockets. So as soon as this story about SpaceX and this upper stage crashing into the moon happened, the first thing I thought was, I need to get Jared.
Yeah, I mean, I know a whole lot about very little, let me tell you. So it's a very niche subject. I definitely live, eat, breathe, sleep rockets. I mean, I got rockets in my bedroom at home. So like actual flown rockets. I don't think it gets any more enjoyable than that, I guess.
So in this circumstance, how did a SpaceX rocket end up on a trajectory for the moon?
Well, we have to go back to last year in early 2025 when this specific SpaceX rocket was used to launch a dual mission. So it was the Hakuto R mission that was going to be landing on the moon along with the Firefly Aerospace Blue Ghost mission. And Hakuto R, unfortunately, did not work. It crashed into the moon. But Blue Ghost actually did land on the moon and became the first successful commercial lander at the surface of the moon.
I also want to point out that that was the one that had the Planetary Society SciTech project on it, PlanetVac, that is now going to be going to the Martian moon Phobos on the MMX mission. So I loved watching that land on the moon. I'm glad they succeeded.
Yeah, so what you're telling me is that the stage crashing into the moon is actually the Planetary Society's fault.
Inadvertently.
So inadvertently. You contributed to this. How could you? But yes. And so after this launch, once an upper stage fires, they will passivate the upper stage, which basically means that they'll vent out all of the propellants or the fuel and oxidizer that's on board and shut down batteries and other things like that. You basically want to do everything you can so that your upper stage doesn't blow itself up. Mm-hmm. We've had that happen in the past in low Earth orbit with several upper stages that weren't passivated. So there is incentive to make sure that that doesn't happen. Going out to somewhere like a expected heliocentric orbit, or basically firing to the moon, obviously your upper stage is not going to be on the same course that Hakuto R and Blue Ghost are going to be on. As they're on their way to the moon, they're going to do mid-course corrections and then eventually burn to go into orbit to land. So this upper stage was not really expected to stick around, but if it goes to the right spot, based upon where you need to put your payloads, your intended injection, translunar injection for that, you could end up getting something like what we had here, which is that upper stage actually didn't go into a heliocentric orbit or an orbit around the sun. It just actually kind of stuck around the Earth-Moon system. And then eventually, just because of the way gravity works, it just so happened, completely unintended, that just a few days ago, the upper stage impacted the moon itself.
Do you know where on the moon it came down?
Yes, it came down just on the limb of the near far side, near Einstein crater. So it's really brought the land value down on that portion of the moon, so it should be easy to get that.
My understanding is that an independent astronomer, Bill Gray, actually detected this thing. He works for the Pluto project out of Maine, and he's the same one who actually found that Chinese rocket stage that crashed back into the moon in 2022.
Yes, yeah, Chang'e 5 T1, the upper stage for that, which was a lunar sample return mission, if I'm remembering correctly.
From the far side.
Yeah, from the far side. The upper stage of that Long March rocket impacted the moon as well. So not an unprecedented thing in terms of objects that we have sent to the moon running into the moon. Definitely unintentional. Most of the stuff that has hit the moon was intentional to hit the moon. Some of it was unintentional to hit the moon, and some of it was trying to land on the moon and just decided to litho brake instead of a nice soft landing. So
I think it's interesting, though, that space agencies and space companies ostensibly are tracking just bunches of these objects that are in cislunar space. But in this case, it was this amateur astronomer that detected it first and then notified everyone. Why was that the situation here? And why wasn't SpaceX aware that it was going to be crashing into the moon earlier?
Well, I feel like once you leave low Earth orbit and you're going into a heliocentric orbit, a lot of your responsibilities are absolved at that point, simply because at the moment, there is no regulatory environment that controls what you do in cislunar space. And a lot of that comes from the fact that we just don't actually have anything that really would require a robust regulatory environment yet in cislunar space. Now, obviously that's coming, right? Because with the Artemis program and everything, they're talking about doing like 8 landers a year, 8 robotic landers a year. to get there, right? That's what NASA Administrator Jared Isaacman said at the NASA Ignite event from earlier this year, is that they're going to do 8 landers annually on the surface of the moon.
Many.
That's a lot, right? That's a huge amount to do annually. So that means you're going to have a lot of traffic going on up there. And you're going to want to make sure that you have a good understanding as to where your leftovers are at while you're up there. So there may be something that needs to be put in place that either makes sure that your upper stage or whatever you're having to use to get your vehicle to the moon or get it to land on the surface even actually is clear of the moon and into a heliocentric area or impact in a certain area. So sort of like what we do here on Earth. Rocket launches, you put your payload into low Earth orbit, and then you deorbit your upper stage in usually the Indian Ocean or near Point Nemo in the southern Pacific Ocean. Mm-hmm. And you put out these things called NOTAMs, which basically tell people on boats and airplanes, don't go here because you will get hit by re-entering rocket debris. So we might have to actually start figuring out how to develop like a lunar NOTAM system, possibly. It's really wild to think about the fact that we may actually be like a year or two away from having to start to take consideration for things consistently hitting the moon that we have sent there. And it is a good thing to start thinking about that now, as opposed to thinking about it maybe 3 or 4 objects after it started to happen.
Correct me if I'm wrong, but I think the Artemis Accords actually have provisions that deal with the safe disposal of, spacecraft and rocket components. But, it's kind of just a set of guidelines, right? It's not like it's enacted as an actual law. So even if they're beginning to take those steps, we don't really have any regulation currently.
Yeah, it's essentially a set of nice to haves as opposed to a you must do's. Mm-hmm. But the nice thing is that most operators are looking at those as you must do's. So in this case, with something like SpaceX's upper stage, it was just simply, this is going to go heliocentric, so we don't have to worry about that. Turns out it didn't actually have enough oomph to go heliocentric, and the gravity just ended up causing its orbit and trajectories to change, and it just so happened to end up hitting the moon. So that regulatory framework may not be there in writing. The ink may not be there for it, but at least in terms of companies that are doing these kinds of things, most of them are thinking about that. Most of them are preparing for things like that. Most of them are trying to accommodate these things as best they can. But obviously, 99 times out of 100 still means 1 out of 100. So,
I mean, as weird as this is a good opportunity to do some science if we're going to be crashing something into the moon. Inadvertent results, but what can we actually learn from watching an impact like this?
Well, you can figure out a lot of things about like soil mechanics, or in this case, regolith mechanics with the surface of the moon. You can also determine things like, I was hearing that they were looking at spectral lines that were actually coming off of the dust plume that came off. I saw a video of the dust plume that actually had been taken, and it's just like this faint whisper coming off of the surface of the moon. But it's still cool to know that like something 2/3 the size of a city bus smacked into the moon, traveling at 2 kilometers a second, and blew this material, up for you to be able to see that. But I saw those spectral lines. They were talking about the 2 main things that they found in it was sodium and lithium. And sodium, they were expecting, because there's a lot of sodium in the surface of the moon. So if you kick a bunch of dust, you're going to detect sodium. And then the lithium actually comes from the rocket itself.
Oh, that makes sense.
Because Falcon 9s use a lot of aluminum lithium alloy. And in fact, pretty much just about most rockets for their tankage and other things like that use aluminum lithium alloys because they're great for cryogenics. They're very lightweight. They're strong. They do exactly what you need to do as somebody who's designing a rocket. So to be able to detect basically the guts of that rocket upper stage, vaporizing on impact, I think that's a really fascinating result as well. And that may tell you a bit about how the impact went down, and eventually you could, I don't want to say use that as a tracer, but you could even see just how far that material went, which could then allow you to determine what exactly will happen to a moon base on the moon if something like an upper stage hits the moon.
Oh, man, that would be a whole crisis. We definitely need to figure that out early. But do we know how far the ejecta from this collision went?
So not at the moment. Nobody really has a good idea at the moment. Probably got to wait a little bit longer for those results to come in. And also imagery will help with that as well. I know the South Korea satellite that's in orbit around the moon right now, Danuri, they actually did do a series of images. I think it was somewhere on the order of like a half hour before the impact, and then continuing to take images until 16 hours after impact. And we already do have an image of the actual area where the impact occurred. And we could see the crater and ejecta from the crater as well. We could see how it has affected the environment locally, which is really cool to see. So it looks like the crater is about somewhere in the order of like 60 feet across and maybe about 15 feet deep. So, big enough for an upper stage to fit inside of, with a little extra room in the width and the depth of that there.
Do you know what that is in metric for our friends across the pond?
Yes, I think that should be close to just about 20 meters wide, I want to say, and maybe about 5 meters deep, plus minus 1 meter on that there. So non-freedom unit, measurements there for you.
That's still pretty big.
How many bananas?
How many bananas wide?
Must be a lot of bananas.
Banana for reference.
Yes.
But I mean, as our NASA administrator, Jared Isaacman, pointed out, many natural meteoroids crash into the moon, making an impact of equivalent energy all the time. It's like roughly every 6 days on the moon. So if we're going to be dealing with that just naturally in the environment, should we also be worried about rockets crashing into the moon once we have these crude settlements?
I think a lot of the regulatory work will help out with that. Obviously, if you're going to start a moon base, you don't want to be dropping things on the moon, causing problems for everybody there. And I think it's important to remember the United States is not the only group that is going to have a moon base. China is going to have their lunar village, right? And they're working with, we're working with the Artemis Accords here in the United States with 20 plus countries to make our moon base, which is called Moon Base, happen. And then China's working with a multitude of countries as well, because, we can't collaborate with them. So they've rightfully taken their ball and gone to play with other people. Obviously, I don't think the United States or China wants to be dropping upper stages near each other and pelting each other with lunar regolith and rocks or boulders that may come from that. It's usually considered being a bad neighbor. I don't know about you. I personally don't drop my rocket stages near my neighbors in my neighborhood. So I would imagine it would be very well frowned upon. So things like the regulatory environment are going to likely be put into place. And I also can't imagine a company willingly allowing themselves to get these public headlines about, dropping equipment near a base and threatening the lives of astronauts that may be there. That kind of starts turning into like a Weyland-Yutani situation of expendable people, right? And that's typically for a private entity, that's usually a very bad thing for you to start getting press like that. And admittedly, I feel like it's a really important thing to point out, which is that a lot of the coverage, media-wise, of the upper stage hitting the moon was very sensationalized. So they made it sound like it was going to blanket the entire moon in this layer of meteoritic material, and it was just going to be really bad and everything. But it turns out it's just a very, very localized area of the moon that had to deal with that. So because of that, it's important to make sure that also when we are talking about these things, that it's understood that at the moment, this is a very localized kind of event and a very rare kind of event. But you do bring up a great point, which is that when we start doing this regularly, we have to hopefully have something in place that can actually have, I don't want to necessarily say teeth, but definitely remind companies that hey, there's some due diligence that you need to do. And that shouldn't be too difficult for companies to do. They already do that for the most part with low Earth orbit.
You spoke a little bit about this earlier, but if we need to be sending things all the way out to the moon, what would be a good way to dispose of the upper stage of the rocket if you can't re-enter into the Earth's atmosphere?
So having a little bit of propellant on board, saving a little bit to burn into a heliocentric orbit would definitely help Once things go into a heliocentric orbit like rocket parts, it does become a bit difficult to track them. They are very small, not impossible. You can obviously track them with telescopes here on the ground and then develop orbits and ephemeris and other things like that to be able to determine where they're going to be at like your best guess at that time. And then maybe either you could use a telescope further on down the line to try to confirm the location of it years down the line, as long as it hasn't run into something in our solar system. But also, don't get me wrong here when I say this, because we're just talking about, I don't know if it's so great that all these things are running into the moon, but it may actually behoove us to pick a disposal area.
Our new Point Nemo.
Yeah, a new Point Nemo or Point Luna, maybe.
Ooh.
Or Lunemo? We'll workshop it later. That might work very well. And it might also work from a scientific perspective as well. So in the Apollo missions, they put seismographs on the surface of the moon to measure the lunar seismicity. And one of the things that they did with that big Saturn V, the third stage, after it was done with the translunar injection burn, they would actually re-aim them to smack into the moon. So that way it could generate an impact, which would generate seismic energy, which would allow that to propagate across the moon. And from that, they were actually able to determine things like the interior structure of the moon and also what happens when you have a moonquake. Because that's the thing. I think people forget about the fact that the moon has seismicity. It's different than what we have here on Earth. Mm-hmm. The mechanisms are different, but you still have moonquakes. So if you build a moon base, you're going to have to actually make sure that you build it for moonquakes as well. So I don't know, maybe they should take the design, lift the design from us here in Los Angeles, since we deal with earthquakes constantly here. But I feel like there's a really good scientific component that could be done by smashing your upper stages into a designated area at the moon.
You also bring up a good point, which is that this one was an accident, but there have been many times in the past that we've crashed things into the moon on purpose. Mm-hmm. This is just one example, but yes. Do you know how many objects we've actually crashed into the moon?
So if you are looking for a total number of objects that we have, that humans have made, artificial objects that are on the moon, this upper stage was the 104th human object that has made its way to the surface of the moon. So it is not like we have exactly done a good job of keeping trash off of the moon. Now, some of that comes from very early on in the original space race 1.0, whatever you want to call it now that we're in the new space race. And that was, the United States and the Soviet Union competing with each other. My missile is bigger than yours. Instead of a nuclear warhead at the top, it's a human. Or in this case, for a lot of these, is a scientific probe of some sort with instrumentation and just getting it there. And a lot of that just get it there attitude meant that very early on in the 50s and 60s, multiple times a year, we were dropping things onto the surface. Most of them obliterated. Some of them survived and are still probably sitting there today. But a really big gap happened up until, once you reach the early 70s, you get a big gap until the mid 90s. And then we suddenly get interested in the moon again because there's water ice on the moon. There's water on the moon. Who'd have thunk? Now we definitely got to go back. And then once that rolls around, oh boy, here we go. It's on, baby. And then you see that rise in objects getting to the surface of the moon again. Although in this case, it's not often landers that don't make it or impactors. It's usually just disposal of a probe that may be in orbit. One that I really think about is the 2 Grail spacecraft, the gravity recovery mission where they mapped the gravity of the moon. They literally mapped the gravity of the moon, showed how lumpy it is, which is a huge problem if you're trying to have something orbit the moon very precisely. Or a big problem too if you're trying to do a flyby of the moon with, say, your upper stage to make sure that it goes in the heliocentric orbit. So to end that mission, they flew both of them into the side of a mountain on the moon to dispose of them. So that way they were not in orbit anymore, passivated, and not a dead spacecraft in orbit with a location unknown that we might run into. Space is big, but you can still run into stuff. So it's happened in low Earth orbit before. So we don't want that to happen in lunar orbit. So dispose of it as best you can.
You mentioned the discovery of water at the South Pole of the moon as well. And that brings up the L-Cross mission for me, which was another one of those purposeful crashes into the moon.
Yes, that was such a cool mission. Actually, I have a friend of mine, Vax, who worked on that mission. We jokingly call him our resident Moonabomber. And he's a very, very cool dude, very cool engineer. And L-Cross was such a neat mission. They launched it with Lunar Reconnaissance Orbiter. And it was a spacecraft that was attached to the Centaur upper stage of the Atlas V rocket that had launched it, and they did a pretty weird orbit, kind of hanging around the Earth-Moon system until they finally lined it up using the gravity of the Earth and the Moon together to smack it into the South Pole, like you mentioned. They had a separation between the spacecraft and the upper stage, and the upper stage actually went in first, smacked into the surface of the Moon. Big plume came up. And then a couple minutes later, the L-Cross spacecraft flew through that plume and detected everything that it could on its way down before it eventually also smacked into the surface of the moon. Obviously, lots of telescopic observation from here on Earth, and also observation from other spacecraft that happened to be in orbit around the moon at that time as well. Several of them were moved in order to maybe potentially try to fly through that plume to detect, or just to have a good view of the plume to analyze it. And yeah, that was basically like slam dunk confirmation of water ice on the moon.
It's kind of funny that the mission that kind of proved that we found water on the moon, clearly the other missions before it were the ones that first did the detection, but we purposefully crashed a spacecraft that then told us there was water on the moon. That water on the moon now enables permanent lunar settlements. And now we have to worry about rockets crashing accidentally. So there's a fun arc there.
Yeah, time is a flat circle, it turns out. What was old is new again. So here we go once again. And that wasn't even the first time we crashed something into the moon to try to find water for it as well. The Lunar Prospector mission, which was sort of NASA's return to the moon after the Apollo program, that flew, I believe it was late 90s. And then it actually crashed. It was, at the end of the mission, crashed it into a permanently shadowed crater, because Lunar Prospector had an instrument on board that basically did the first detections of evidence for water ice on the moon. So they said, okay, we're going to crash it into one of these permanently shadowed craters to kick up a plume in order to detect it. And when they did, it was inconclusive, which I always thought was very interesting, that like it had this slam dunk evidence of like, yes, it's there. And then they smashed it into the moon, and maybe they picked the wrong spot. So it happens to the best of us. So also, I was a little kid when that happened, and I heard about it on the news, and I went outside at the time to look at the moon and didn't see the plume. And I got so frustrated at that. And I was just like, why again I see the plume? So a nice little introduction to science for very young Jared there.
Oh man, what a weird time to be having so much human activity going back to the moon. So much so that now we got to worry about accidentally crashing into it and finding out on the news. Thankfully, this wasn't as sensational as all the news stories made it out to be, but still a really cool story.
It is. And, every once in a while, it is a story that does get the attention of the right people. And in industry, it is one of those things where it has kind of made a lot of us in aerospace go, maybe we should think about these things. So don't worry, the cries of the masses, however many dozen of the folks may be, myself included, right? Like, I'm throwing myself in here that we need to start thinking about these things. Industry did pay attention a little bit to this. It was a little too difficult to not pay attention to it with as much coverage as this got. So, and I will admit that I was thinking possibly about taking my telescope out to try to see if I could catch the plume. But now I'm very glad that I didn't, because I saw a video that was taken, and man, it was just such a wisp from that I would have had no chance. And then it would have been me 20 years later going, man, I couldn't see the plume again.
Well, seriously. Anytime I see a rocket story, you're the first person that pops into my brain, and I'm so happy to have an occasion to bring you on the show, and such a fun story to go over. So thanks for being here.
All right, well, thank you.
We'll be right back after this short break.
Hi, Bruce Betts here, Chief Scientist at the Planetary Society. Our organization is strongly committed to defending our planet from an asteroid or comet impact. Thanks to the support from our members, we've become a respected independent expert on the asteroid threat. So when you support us, you support planetary defense. It's a lot to do, and your support is critical to power all this work. That's why we're asking for your help as a planetary defender. Together, we're advancing the global endeavor to protect the Earth from asteroid impact. Imagine the ability to prevent a large-scale natural disaster. You can be part of this global effort. A gift of any amount to the Planetary Society helps keep this critical search going, protecting our planet and everyone on it. Visit planetary.org/Defend Earth to make your gift today. Thank you.
Over the past few months, we've been covering the ongoing situation with the NASA budget and the proposed changes to the Office of Management and Budget's federal grant-making rules in the United States. Jack Corelli, the Planetary Society's Chief of Advocacy, is here with an update on our campaign to save NASA science. Hey, Jack.
Hey, Sarah. How's it going?
Doing well. It was really wonderful seeing you in HQ a couple weeks ago.
Yeah, no, that was a fun little West Coast trip to kind of round out my summer travel. So it was good to be in town. Good to see you and good to see some folks in Southern California.
Also cool to get to celebrate a little bit in person your new position at the Planetary Society. Congratulations.
Thank you. Yeah, Chief of Advocacy. Can you believe that?
I can, actually. I mean, with all of the work that you've been doing, it is so well deserved.
Well, thank you, Sarah. And it's been really humbling to kind of step into this new role and still do a lot of the same stuff we have been doing over the past year, but really goes to show how our organization is growing and changing and adapting to this moment that we find ourselves. And so I just, again, very humbled by the support from our leadership team, from our members, and from others in the space community.
Well, when last we heard from you, we were in a kind of predicament here, right? Not only was the presidential budget request proposing another very massive cut to the NASA budget, but we also had the situation with this procedural rules change behind the Office of Management and Budget concerning grants given to scientists. So I wanted to just take a moment to give people some news about what has actually been happening and where we're at with all that process. So what's the deal?
Yeah, so a lot has been happening this year. It feels like it's just been a constant stream of new developments and new crises in some cases. So, of course, we are still in the midst of a budget fight for the future of NASA. A budget for fiscal year 27, which starts on October 1st of this year, so just under 2 months away. We have not come to an agreement on a budget yet in Congress. So the president's budget request, that OMB-led document, Office of Management and Budget, their document that really, it's the 46% cut to science, a 24% cut overall to NASA, lacks a lot of the details about accelerating the Artemis program, the moon base, a lot of these new projects that I know people are getting really excited and are interested in, like Skyfall and Moonfall and SR1 Freedom, and how they all fit together. And the budget just failed to provide a vision of a expansive, ambitious program of exploration and science at the agency, but still is the official budget request. And only the House of Representatives has put out a counter proposal. The Senate left town 2 weeks ago, having not passed a budget or even released a draft budget framework for NASA's budget for fiscal year 27. So that's all happening. Meanwhile, the Office of Management and Budget has proposed what are called the uniform guidance changes. So changes to 2 CFR. We can go into the fun acronyms and structure of federal regulations, but functionally, it is a massive overhaul of the rules that all federal agencies that give out grant funding, the rules that they have to abide by. And so some of these new rules include the insertion of a political appointee to make a determination about grant funding decisions, and they can only consider not the peer-reviewed science, not whether this will advance, scientific discovery or lead to the next great innovation, but whether or not that scientific activity advances the political priorities of a given administration. And so whether you agree with this administration or not, this would create this new framework for how science is like what science the government funds, because that's a basic function of the US government. It is the thing that won us the Second World War. It's the thing that catapulted the US into a prominent spot in science and technology innovation in the 20th century, and has really been the foundation of life in the 21st century, is having this, government funded, fundamental science research. Companies, they do research and development, of course, but they're focusing on immediate products and applications. We're talking about the fundamentals of understanding, in the case of space science, understanding the history of our universe, understanding the processes that take place in our solar system and around, other stars and throughout the universe, and really answering these, again, fundamental questions that no company, private research institution, anybody is able to pursue on their own. And that has historically been based on scientific merit being the primary driver. These new rules would functionally put a political appointee, someone whose job is only there for, a handful of years, at most 8 with a given administration, if they win 2 terms in office, that they're deciding the direction of scientific research, not the scientists who know the subject matter themselves. In addition to that, those new political hurdles for grants, you would also see basically a shutting down of public outreach programs. Grant awardees would not be able to use the money that they use to do the research to then share their research at conferences or, community events, or even publish their work. So we're paying people, even if it is a scientific topic that aligns with a given administration. Again, not saying just this one, but any administration in the future. They would not be able to publish it, right? We're paying them to do the science. We should also be paying to publish it as well, right? That's how you advance science, right? As you get published. In addition, there's these other research and development priorities that have been put out by the Office of Science and Technology Policy. I feel like I'm just speaking in alphabet soup if I just said acronyms, but OSTP in that case. And Casey and I and Zach Pirtle from Arizona State University had a great conversation about this on Space Policy Edition earlier this month. This is all to say, we're dealing with this kind of multi-front crisis to the way that science is prioritized in the United States. Both the funding side, which is very important, right? Nothing gets done unless people get paid to do these things, but also the policy direction and the legal and policy frameworks that enable these things to happen. And so slowing down the ability of scientists to do science and not giving them the money to do it is not a winning combination.
There's also the issue of how long it takes to do these kinds of planetary missions. I mean, going out to a world takes a long time. Building these missions can sometimes take decades. And even if it's something close by, like the moon, the Artemis program famously was one of the only moon programs that got humanity back around the moon because it survived that political transition. So there's so many things that could be completely upended by this kind of change. But happily, we did have a period where people could write in their opinions on this OMB uniform guidance change. So what happened there? How many people wrote in?
So pretty amazingly, more than 60,000 people wrote to the OMB in response to these proposed changes to grant-making rules, this uniform guidance. That's a high watermark for this. Granted, we've never seen a attempt to change the rules governing what research is funded. We've never seen such a drastic overhaul, so I think it warranted quite a drastic response from the public. But this is all part of the regulatory process in the United States. So when an agency puts forward a change to the regulation, there's a public comment period. Now, for the 200-something pages, of changes that OMB was proposing, we only got 45 days to internalize and understand what these changes would do and write a response. And so the fact that 60,000 people took part in that effort is truly amazing. And the results speak for themselves. There was a great analysis done because, these are public comments. And so they live on a website somewhere, but it's not like you indicate whether you're for or against something. So you really have to read these comments. Well, a group of researchers took this upon themselves to analyze all of the responses so far and kind of categorize them and determine, which ones were pro, which ones were against, and what the content of the comments were. And amazingly, and I think this goes to something we're about to talk about in relation to the congressional and even administration response to this, is that 95% of the submitted comments were in opposition. Right? You don't get 95% of people agreeing on much these days, but you got 95% of comments were in strong opposition. The remaining 5%, right, the ones that were in support, almost all of them were form submissions. So they were not personalized. There was nothing unique or personalized about them. Were form submissions. So those could be real people, right? That could be, people sitting, putting their information in on a website and hitting submit. But, it's not representative of the opposition side, right? That 95%, where most of those comments were personalized. It is researchers and students and academics and commercial industry people, elected officials, just really a cross section of society came out to say that these proposed changes to the uniform guidance would be detrimental to the American scientific enterprise. And as of recording this, as of August, the OMB has not even announced whether or not they're going to move forward with implementation. And this is where we get into sort of the current state of play. And this ties into the funding question too. So if you've been following the appropriations process over the last few, 30 years, we always begin the year with what's called a continuing resolution. This CR basically is the equivalent of taking the Excel spreadsheet of government funding and, grabbing the little box in the corner and shifting it over to the right a couple cells to cover, the first few weeks, maybe, as short as just a few weeks into September, or in the current case, talking about extending temporary government spending until early December. The House put forward a version of their bill and passed that before they left town in the middle of July. They passed a bill that's called a clean CR. There was no anomalous language, basically nothing other than just saying, yes, take that Excel spreadsheet and, drag it over to the right a little bit. There was no additional guardrails, no, special call outs of specific programs, to the point that even the administration was a little lukewarm on this proposal from the House. And so it passed on functionally a party line vote. Only a handful of Republicans voted no and a handful of Democrats voted yes in the House. And so it's, this pretty partisan bill. The Senate, on the other hand, before they left town at the beginning of August, they released a bill that, in addition to extending government funding through December 11th, so giving the Congress basically 2 months, kicking everything beyond the midterm elections, and giving them more time to work on full year appropriations, they included a very important section, which Section 157 of the bill, which pauses implementation of the OMB uniform guidance changes through that same end date. And so basically kicks all of this into the future and prevents OMB from following through on what their original intent was, which was enacting these changes on October the 1st.
It's so relieving to hear that so many people wrote in and that the Senate has included this, right? I mean, this does give us an opportunity to kick the can down the road at least a few months and kind of hopefully let OMB percolate on this, but it still doesn't mean that we've won this battle. We're still looking forward to what's going to be happening after that.
Right. And, admittedly, it is an election year. And so a lot of the big decisions about government funding, in this case, the uniform guidance changes, a lot of that is getting kicked over until the very end of the year after the elections have concluded and they've certified the winners. The control of both chambers of Congress is in the balance this year. And so it really could be a really, seismic shift happening here in Washington, depending on the results of those elections. And Congress is only in session where they only have work days, right? Where that they're actually in session and do votes and have committee hearings and do their normal activities. 40 days. They have 40 days left, functionally, before the end of the year. And so that's not a lot of time. And so they really need to be focused. I think it's positive that these two issues have been linked together because ultimately they're two sides of the same crisis that are facing NASA and science overall. This allows the Congress to address both of these issues, keep government funding flat for this first part of the fiscal year into December, and also pause implementation of the uniform guidance. Because ultimately, OMB has to respond to these 60,000 comments. I don't think they would have been able to really meaningfully respond to the comments between the close of the public comment in mid-July and adequately respond to them by September 30th. 60,000 is a lot. And you have to, it's not just you have to open it and read it, like you have to materially change the guidance to prevent any harm from being done as outlined in those comments. And so, and that is also then the basis of what would eventually become a long and drawn out legal battle. If OMB, even if they made minor changes, again, 60,000 people, 95% being against, clearly there is some harm that this would do to the American public. So OMB is stuck in a really tough place with trying to move forward with this uniform guidance. Now, what's really a kind of fun twist on this that kind of is developed in that final week that the Senate was in session this first week of August is that in addition to the 90 members who voted for this CR that includes this provision delaying implementation of the uniform guidance, the White House released a statement of administration policy, a SAP, if you will. It's the fun acronym. We love acronyms in the government, but the Statement of Administration Policy.
It's so funny because it's like the thing that space people and the government have in common is our love of acronyms.
Well, maybe there's a connection there.
Probably.
But so the administration put out a Statement of Administration Policy endorsing this CR, not only just saying, this is something, we really need to solve the government funding question. Like putting out a Statement of Administration Policy is as close as you can get to a functional endorsement of something. And so clearly, either the administration sees how unpopular the uniform guidance changes are and are willing to start walking away from it and see this as a vehicle to do so, or it's not important to them to make these changes and they're prioritizing extending government funding into December over enacting these changes. And so either way, them coming out and supporting the Senate bill over the House bill is really significant. And I think probably is what led to that, the 90 senators voting for this bill and only a handful voting against. Now, the House needs to come back into session and vote on that version of the bill. So we are asking people during this August recess, while these members of Congress are back in their districts, probably a lot of them doing events and holding town halls and community events to hear from their constituencies, we're asking people to write to them, to go to these events and talk to them. If you can, set up a meeting with your legislators while they're in the district and tell them why it's so important that we need to preserve the scientific integrity of the American scientific enterprise, that science is a key driver of these things, and encourage them, especially if they're members of the House. The Senate's already done their job, but if they're members of the House, ask them to include Section 157 in the final version of the continuing resolution that gets passed. Ideally, they're just taking the Senate bill and voting for that, and then it goes to the president, he signs it, and then we're good to go. But it's Washington. You know how these things go. Sometimes there's a last minute push to get a new legislative vehicle to the floor. But what I'm saying is planetary.org/action. You can write to your members right now, encourage them. It's the top action that we have on our website right now. Encourage them to include this very important provision in whatever deal comes, whether they vote for one bill or it comes out of another bill. Like, this specific provision is very important as part of the larger crisis that NASA science is facing.
Well, clearly there's still a lot of work left to do, but this is a heartening update given what we were seeing earlier this year. And honestly, after accomplishing the saving of NASA science last year and seeing this public backlash against these changes, I have a good feeling that maybe this will actually turn out in a way that is favorable to the scientific community.
Yeah, it just goes to show that when people come together under a common purpose, Republicans, Democrats, independents, progressives, conservatives, people of all ages and demographic backgrounds, and it really goes to show what we're able to accomplish together. This is ultimately a nonpartisan issue. Science has, for a long time, and specifically space science, has been a nonpartisan issue. That's why you're seeing so many members of both parties coming out of the woodwork to show their support for NASA and for NASA science. We saw it last year. We're starting to see it again this year. Again, we have to deal with this politics of a midterm election. And so we are not the people, nobody's running on space as a number one priority, right? That's just the reality we have to acknowledge. But we have to fit within this ecosystem, right? And we have to work with people regardless of who's in the majority and who's in the minority in Congress. Everyone has a reason to support space. And we need to communicate our passion and our interest in solving some of these big challenges to our legislators, because oftentimes, although they might agree with us on these things, they might not know that there's an opportunity to support the space sciences. Members of Congress deal with literally thousands of topics. And so giving them this opportunity, letting them know that you as a space advocate are concerned about these uniform guidance changes, you're concerned about proposed budget cuts, communicating that to your member is very important. And again, if you go to planetary.org/action, you can see what actions we're currently running, what letters, we're asking people to send to their members of Congress. I encourage you to stay involved with our advocacy efforts. We need to stand together because we can accomplish so many great things when we do so.
Well said, Jack. And thank you for the update on a really complicated situation that I know has probably alarmed a lot of people. This is some good news. Good luck over there in Washington, D.C.
Thanks, Sarah.
Earlier, Jared had mentioned Point Nemo, the remote spot in the South Pacific where humanity sends spacecraft to die when it's time to bring them down. It's called the Spacecraft Cemetery. But it got me curious. Just how many spacecraft have actually ended up there? Dr. Bruce Betts, our chief scientist, joins me for What's Up to find out. Hey, Bruce.
Hello, sir.
So we get to talk about all kinds of fun stuff this week. We got eclipses, we got rocket crashings, we got space policy updates, but I just have to say I was so excited to bring my friend Jared on the show to talk about rockets. There's almost no one I know in the entire world that knows more about rockets than that guy, except for maybe the everyday astronaut.
Rocket guy. He's a rocket man, is what you're saying.
Rocket man. Yeah. We talked about the SpaceX upper stage that crashed into the moon. And as part of that conversation, we were talking about where spacecraft go when it's time for them to not be functioning anymore.
No time has passed.
Well, I mean, most of them kind of like burn up in the atmosphere, right? But a whole lot of them, if they're really big, they end up at Point Nemo. And Jared brought this up. I know you and I have talked about Point Nemo in the past, but I don't think we've ever talked about how many objects are actually crashed at Point Nemo.
It's actually fewer than I would have expected. Apparently about 300 since the early 70s anyway. Your run-of-the-mill spacecraft can hit the atmosphere and burn up completely before reaching the surface. But your big suckers will break into pieces that will survive to the surface. And that's why they do Point Nemo, the farthest point from land, I guess, that there is on the Earth, and also less shipping traffic to plan around. So big things like old space stations definitely get targeted there. It's the spacecraft cemetery. It's also known as the South Pacific Ocean Uninhabited Area. It's east of New Zealand, and you find the place that lacks islands as much as possible, and things like Mir and 6 Salyut space stations of the Soviets, Progress spacecraft, Japan's transfer spacecraft, ESA's transfer vehicle, all targeted there. Things that have been targeted there that didn't hit there, like Tiangong-1, the first Chinese space station. Skylab, going farther back, is fun because one thing I won't present as a rewind random space fact today, but it came back in 79 and splattered some pieces across Australia, Western Australia, and the Miss Universe contest was a few days afterwards in I believe in Perth, and definitely in Australia, and they had big chunks of Skylab on display.
That is so funny. Like, I had heard that Australia basically took legal action against NASA for littering, but I had not heard that story. That is funny.
Yeah, no, there are pictures. It's fabulous. ISS, when they finally give up on it, of course, we'll go there, being humongo.
Oh, that's going to be such a thing. And it's so far away from humans. Like, is anyone going to be there or close enough to witness the crashing of the ISS into the ocean? Probably not, right? What a thing.
It's probably something you don't want to be there, although I guess statistically it would still be pretty unlikely that any piece would hit you.
That's true. But even then, man, the footage, it would almost be worth taking a boat out there. It also makes me happy to know that there's not a lot of life living out there, right? Like you mentioned that it's a South Pacific Ocean uninhabited area. And when I looked it up, it's like the water is less oxygenated, so there's not as much life in that part of the ocean.
Really?
So, you're less likely to even hit the fish, which makes me kind of happy because that would make me really sad.
Huh.
I mean, can you imagine? You're just a fish doing your thing in the ocean when here comes the ISS. Like,
I got to say, no, I can't.
Nope.
I can't imagine that. You lost me at imagine you're a fish. And speaking of thoughts, we move on to
Random Space Fact.
So, Apollo 11, probably heard of it. The two major pieces were named Eagle and Columbia, as in the Eagle has landed. Before they received their official names, they were named or nicknamed as part of operations and communications and planning, Snow Cone and Haystack.
What?
Because of kind of the way they looked, with the top of a snow cone being the command module and a weird haystack with things sticking out being the lunar module.
That kind of makes sense. Although I like the new names better, but
The haystack has landed.
Can you imagine?
All right, everybody, go out there, look up in the night sky and think about Point Nemo, Random Nemo, Me Nemo, Space Facts, Submarine Nemo, Fish Nemo, where it is. Where is your personal Nemo? Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. I'm really looking forward to this next episode. We'll be discussing the upcoming launch of the much-anticipated Nancy Grace Roman Space Telescope. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review or a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, poetry, or your eclipse images at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our online member community. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members all over this planet. No matter where you live, you can join our merry band of space enthusiasts at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Matt Kaplan hosts our monthly Book Club Edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.